Hi, thank you for being here. My name is Eyal Keren. I'm located in Tel Aviv, and I'm the Chief Product Officer of Wing, which we are a company. We have an open source project, and I'm going to talk about this uh, um, quite extensively during the next hour also. This kind of workshop on Zoom it's a very long thing to do. So I've asked one of my colleagues, Uri, to join and to basically help me ask the questions. He doesn't know what I'm showing, so he's going to be completely surprised. So he's going to be here exactly like this. So thank you, Uri, for doing this. Uri is Director of Engineering in our company. And making sure you're seeing my screen, and you are. And for our agenda, we're first going to talk about what we're going to build, and then we're going to do a short introduction to Wing, what is Wing, and then we're going to go through the workshop. So that's going to be very simple. Let's start with what we're going to build. I'm clicking on this link here. Exactly. And let me also share this link if you want to play with it. I'm sharing the workshop and the demo link if you want to play with it. Here we go in the chat. Great. And what we're going to build is a very simple React application. As you can see, it is deployed on CloudFront, which is Amazon AWS. Let me open a bunch of those. The application has a title and a counter. The counter is 104. And when I click on the counter, I can see that it automatically gets updated on all systems. We play around with it a little bit. And you can also play around with it, Uri, if you want to click on it so we can see this going, because this is basically, and behind the scenes, there is a counter that is deployed in the backend, API gateway, and we have WebSockets that basically handles the real-time communication. So this is what we're going to build, fairly simple. And we're going to use it, we're going to build this using Vite, which is a toolchain for JavaScript, a very strong toolchain for JavaScript, React, and Wing. What is Wing? Let me tell you about Wing a little bit. So Wing is an open source project, and actually Wing is a programming language, Winglang. I'm going to create your first probably ever seen Winglang file. This is it. And it's a little bit different from any other programming language that you know. So when you think about a programming language like C, it's usually you write code that runs on a computer. So I can open a file, I do fopen, I get a file descriptor, I can read from file. And when I'm done writing the code, I can define where do I compile the code? What kind of computer with this code is going to be compiled? It could be an x86, it could be 64 bits, 32 bits, it could be an ARM, it could be a Linux machine, a Windows machine, a Mac OS machine. And then when I compile it to run on the specific computer, and the output of that compilation is assembler code. So Winglang is pretty similar, but it doesn't run on a computer. It runs on the cloud. So I write my software. I probably don't have files and semaphores like we do in memory, like we have in C. I have stuff that are related to the cloud, kind of the standard library of the cloud. And when I finish writing my software, now I need to define where I compile it to. So if I decide to compile this to Terraform on AWS, I can decide to compile this to GCP on Terraform on GCP, and I can also decide to compile this to Terraform CloudFormation, to Kubernetes on Helm charts. It really depends on my designated cloud. So it doesn't run on a computer; it runs on the cloud. Pretty easy, and we're gonna see a demo that's just gonna explain this. So I'm gonna add code here. This is main.w, the Winglang extension, and I'm just going to bring cloud. Bring is our import statement. So in TypeScript, this language is very similar to TypeScript. And in TypeScript, I would do import. Now I'm doing bring, and I'm going to create a very simple application. I'm going to do new cloud.bucket. A very simple application. I'm going to use the command line here, and I'm going to compile this application. I'm going to do wing compile, and I'm going to compile it into a platform. And the platform is going to be TF, which is Terraform, stands for Terraform -AWS. And I'm going to give it the main.w. When I compile this to Terraform, the output is not assembler. the output for this simple program is Terraform. So let's take a look at the output of this Terraform. I have a main.tf.json file, so it's a Terraform, but in the format of JSON. And I can see I have one resource, an AWS 3 bucket that is provisioned. I can just go to this folder, do Terraform apply, Terraform init, Terraform apply, and deploy this on my own AWS account. I can also do other stuff here. I can do public.true, which basically tells this cloud bucket that is accessible from outside, from the world, basically. So I'm really compiling this. And now I also have some bucket policy that basically allows everyone to read my files. Great. The second thing I can do, let me remove this because this is actually a very bad practice to do. Let me place this bucket into a variable. And let's do new cloud dot. And I have API gateway. I have bucket which people know AWS is S3 buckets, and in Azure it's in Google it's cloud storage. I have counter, which we're going to talk about later. Domain, endpoint, function, on deploy, queue, which can be an SQS queue, a Redis queue, schedule, secret, services. I'm going to go with function. And I'm going to write the in-flight function, which we're going to talk a little bit later. And inside this function, I'm going to do log hello wing. And when I do this thing, and I recompile this, now I go back to main.tf. Now I have a lot of stuff here. I have an IAM role. I have a Lambda function. I have a place that uploads the Lambda function. I also have the permission of the Lambda function. So for those of you who don't know, in provisioning engine, when I write software that will be deployed in the cloud, I need to give every resource specific permissions that can access other resources. And because my Lambda function, this cloud function, doesn't do a lot, there is no permission here, as you can see. And now I can go over here and go to the bucket, and I'll do bucket.put. And I'm going to create a file, file.txt. And let's do hello wing. Now the Wing programming language, a compiler, sees that this cloud function needs permissions to do put inside this bucket. Takes this information, everything here is open source. It takes this information, passes this to the SDK, to the Terraform AWS SDK, and tells them, listen, I need to give this cloud function permissions to do put on this resource bucket. And the TF AWS understand what is the actual permissions that AWS asks for this. And if we go over here, we see that the non-null is turned into an abort and put object, as you can see. And it's not for everyone, it's just for the specific bucket in place. This is the specific bucket that is created. So what happens here that the compiler, the language, the system basically gives me least privileged permissions, the only permissions that I need. If I'm going to get a file, the only permissions that I need in order to be able to run my application that it works. So now I need a get bucket, a get object, and a list. Yeah, but let's go back to putting a file. Now, the nice thing about what I've done here is that, like in C, when I create a file, I get a file descriptor. I don't know what the file system is. I don't know if it's NTFS, FAT32. It really depends how long have you been developing software. I don't have an idea what it is. So one of the advantages for this abstraction is that we can implement this abstraction in many places, in Azure, in GCP, in AWS, but also locally. So now I'm going to run this locally, and on the right side, we're going to see this. My simulator that basically shows me the local implementation of what I've done. So I have a cloud function that actually calls put, as you can see, put on a bucket, and I can go to the cloud function. I'm going to click the invoke. I should be seeing logs here when I click it, so let me click the invoke. Now I see the hello wing here. And if I go to the cloud bucket, I go to the file.txt, I have the hello wing text. This is interesting. So now I have a local implementation. This is not done, that didn't kind of go into the cloud. This is basically we implement the cloud function with a JavaScript function, and we implement the cloud bucket with just a temporary directory. But I can do kind of cool stuff about this. So if I go and do b dot here, I can see I have copy, delete, exist, get, all the stuff that the developer would probably assume that we need to do on a bucket. But if I go and do b dot here in pre-flight, this code that happens here is translated into CloudFormation or Terraform or provisioning engine, while this code as part of the in-flight is translated into JavaScript. So the artifacts that come out from this compilation of this application is JavaScript and Terraform, or JavaScript and CloudFormation, or Dockerfile and Helm chart. We don't really care. So now I do b dot on event. When there is an event on this bucket, give me the file name, and let's just do log event from $file. Sorry. As you can see, we have the blue screen of death on the right side. Let me just save this, and it automatically, when I save, automatically on the right side, the hot reloading, the simulator automatically hot reload. And now when I invoke this function, let me clean the log here. Now when I invoke the function, I will also see the event from file.txt. So, and I can do nice stuff about this. Let me create another bucket. Let upper new cloud.bucket as upper. I'm creating an upper. And now I'm going to do, when the file is updated, go to upper, to put file, and do b.get file.uppercase. What have I done here? I said, create me another bucket, call it upper. You can see it here, it's empty. And when there is an event on the source bucket, let's do as source. When there is an event from the source bucket, now go to upper, put the file name, get the file content from B, and do an uppercase. So if I'm going to go over here and I'm going to invoke this, now if I go to source, I have hello wing kind of mixed characters. While I go to upper, I have hello wing uppercase. And I can actually write tests to verify this behavior very easily. And I can do let f equal, and I can just write test. Without mocking, I can just do f invoke. I'm invoking this function, and I can bring. Let me just do this. F invoke. You know what? I won't write the test. I want to move forward. So, but I can actually write tests locally. I can run them in my designated cloud, and all of this that I've done here right now, I can still do wing compile, tf AWS. And now my Terraform file is a little bit heavier. Now it's instead of, now it already have 500 lines of code, of small permissions, of connecting stuff together. We have an event queue. There's a lot of stuff, the intricacies of the cloud, but I don't like those intricacies. I just want to write code, run them locally, and run them on the cloud. That was my kind of almost 10 minutes of explaining about Wing. Any questions?
We are using the Wing specific language, I can see, because there's those bring and
right
typing like str, so it's like new abstraction to learn. Or can we like use something that exists like AWS SDK with this locally set up?
Yeah, so you can. That's a great question. Thank you. So first of all, I'm showing this in Winglang. Everything I've done here, I can also show this in TypeScript. That's an excellent question. You don't have to use. You can use TypeScript, JavaScript, and Winglang out of the box, and also you can write code that runs on the cloud, the in-flight code in any language in Docker. Secondly, you can also use AWS SDK behind the scenes. When this is published into production, this is AWS SDK. We're using, when I do put file, it will actually call put object on the AWS SDK. This is actually what is done. You can use put object, but if you use put object, you lose our abstraction layer. You can use put object, but then it won't work for a local host. It won't work for your GCP. So that's a decision you can take. And basically, you can basically import any code from JavaScript or TypeScript out of the box with no problem. So as we said, we're going to take this technology and we're going to walk through this. I'm going to post this again. This guide of using React with Vite and WebSockets, and basically building the stuff that we saw before. We're going to build this completely localhost, and then at the end we're just going to do AWS compile to AWS and deploy this to AWS if we're going to have enough time. This will actually take some time. It might be homework for you. So in order to do this, I will just follow through with you on this walkthrough. A little bit of it's quite simple and quite powerful what we're going to be doing here. I was very opinionated about stuff just to make things really, really simple. So the actual folder for the shared counter project and the front end. And you can always copy paste the code. There's some places where the code is kind of fragmented, but I usually kind of end with some for convenience. Here is the entire code that you can just copy paste. So just scroll through stuff and copy paste this. And what I'm going to do right now, I'm going to start the process of doing this. Uri, you should start this as well locally. I'm going to talk through this, just the getting started, so you can see this. So let me not save this. And I start with, I already have Wing installed, but if you don't, so you can just do npm install. Oh, okay. We're going to see this in a second. So I'm going to make the shared counter, and I'm going to cd to this folder. Great. And then I'm going to create a folder with Vite. So I'm doing npm create Vite frontend template React.js. This will actually create just the Vite out of the box implementation. Vite, not Vite, sorry. And then I'm going to make sure that it works. cd frontend, npm install, npm run dev. And what we should be seeing on the right side when this is done, let's wait a little bit, is this nice web page. So as you can see, I have a counter here, very similar to what we've done, but the counter, as you can see, is not shared. So there's different values to the counter, and when I refresh this, it goes back to 0. So the counter is kind of locally to the browser. So this is the Vite application. I'm going to give you 2 minutes. I will remain silent for 2 minutes until this can actually work for you.
Okay, so we should just do the npm run dev, and once the application is ready, we're waiting for the backend part, right?
Right. So once the application is done, that's what you're going to be seeing. And if that's working, we can go through the second stage. Is this working for you?
Yes.
Yes.
Awesome. Great. So now we have, not related to Wing, we have a Vite React, a Vite powered React web page that we saw before. And now I'm going to go and install Winglang. So installing Winglang is with npm install, as you can see. And to verify that the installation is successful, I'm going to do wing capital V, which will give me the version. So let's wait and see. There's always something new in Winglang. I get some warnings that I should ask an engineer why I'm getting them. I think it's something with my Node version. But then I can go and do wing.v, and I have this version running. And now I'm going to create the backend folder. This is where I'm going to have the code for Wing. And let me cd to this backend folder. Now I'm here. And now I'm going to generate a new empty Wing project calling Wing new empty, which will just generate 3 files for me. It's going to generate a package.json, a package.json lock, and a main.w. Let's take a look at this. So I have the main.w, a package.json, and a JSON lock. And it's probably a good time to see actually the code. So I'm going to run VS Code. I have already VS Code installed. As you can take a look here in the prerequisite, if you have VS Code, or IntelliJ, you can actually download and use the official extension or the community extension, which is very helpful because it gives you syntax highlighting. So I already have this installed. So I'm going to use code.dot. It will open VS Code for me. And we already seen this a little bit. So, and this is the actual empty project that I've received. And if I go over here and do wing run, I'm just going to copy this from here. Wing run main.w. It should open cloud function, an empty cloud function. There's a test even here. I can go to the cloud function and invoke it. If I invoke it, I get a hello world response, as you can see here. And this is just a step to make sure that Wing is working on your device. It's a Node.js based dependency, so it should be pretty easy. But I'm going to give you a little bit more time to play around with it to make sure that it works. You can actually hello DevOps.js. And if I do this and I invoke this again, now I have hello DevOps.js. So I can actually play around with the code and see that it's automatically reload. I'm going to give you 3 more minutes to run through this very simple installation, creating a directory, creating a new Wing project, and running it.
I get a sign up to GitHub account.
Oh, right. So that's I almost forgot. So in order to use the console, you get a sign up for a GitHub account, which is just ask for your GitHub account. Do you have one?
Yeah.
Okay. So it's just to get your credentials, just kind of your email, basically. And once we're done with the wingrun.main, let me know when you're done and you see this is working. We're going to actually be moving to the next step, which is actually using Wing in order to run the Vite server. And I'm going to talk about the value that it brings. The Vite server, sorry.
Okay, I'm ready. I don't know about the others.
Awesome. Okay. So till now we had 2 projects, the Frontend project and the backend project. I see that I opened the folder only on the backend project. So I'm gonna close this for a second. And I'm going to do code. I'm going to open this so I can see both folders. And now I have a shared counter with 2 folders, and they are not related. I have the backend, which is a completely Vite React application, a frontend, and the backend is a Wing. Now, I want to have a single development environment. I wanna be able to write code in the frontend locally that will be automatically reloaded, and write code in the backend locally that will be automatically reloaded. And I want them to communicate. So for this, first of all, I need to connect both of them. And in order to do this, I need to install a library, the Vite library in Winglibs. So let's do this. I'm going over here. I'm going to the backend. I'm going to the backend, and I'm doing npm install -save Vite, Winglib Vite. And this, as you would expect, will go into my package.json. We're going to see this in a second. And we'll just add this npm package. Here it is. And this allows me to go to main.w. I'm going to delete this code here. And this allows me to do new vite.vite, and I'm giving it the root folder for my React application. When I do this, and I do wing run main.w, let me close this thing. Now, it's going to open my simulator and also going to open my Vite and React application. And now, I don't need to have 2 places where I basically run my backend and my frontend. The backend is responsible for running the frontend. This is going to be important because when I think about Vite on the local host, it's basically npm run dev, right? But when I think about this in the backend, we have a CDN and we have a bucket, and there's a lot of infrastructure involved in order to know how to take a Vite project and run it on AWS or run it on Azure. And this is something that this project, this library, takes care of it. So when I'm going to do wing compile, I can do this right now, wing compile. If I'm going to do wing compile, now it's going to package the entire Vite. As you can see, it packaged the entire assets, and it's going to create a CDN. I mean, the Terraform is quite big in this situation because there's the cloud formation, cloud front distribution. There's a lot of stuff that needs to happen in order for me to take a static website and put it in a reliable way and on the edge on AWS. So let's go back here. I'm doing again. Let me close those two things. I'm gonna do Winglang again, and now I have this. And the next phase for us is basically now we have a backend and a frontend, but they're not communicating with each other. I need a way to basically pass information from one to another, and we're going to do this in 2 steps. The first thing, we're just going to change the title because the title here is React Vite plus React. Well, I want to add Wing to the title. So let's go through this process of sending data to your Vite app using public env. Now, let's go over here. I have public environment here, and now I can put title. And let me do copy paste. It's going to be easy. Now I have title here, and this basically is exposed if I go to the inspect and I look at the console here. Now I have window dot wing dot env, and now I have a way to expose environment variables for my backend to the frontend. Now again, think about this. This doesn't work only for localhost. This is an abstraction that is implemented in the simulator, but it's also implemented in AWS with Terraform, with Terraform that I don't actually understand. And I don't need to understand. The person who wrote the library understands. So now I have this thing. So the next phase for me is just to basically use it in my source TypeScript. So this is the header, and I'm gonna just replace this with this thing. Let me go over here and let me save it. I have a lot of breakpoints from previous testing. Now when I save it, I have Vite and React, as you can see. Wing plus Vite, I keep saying Vite, it's Vite, sorry. Wing plus Vite plus React. So, and so what I suggest for you to do, this is important because we are about to give a React application the URL of our API gateway. We're going to create an API gateway and give it a URL, and this is going to work across all your environments, simulated and not simulated, GCP, Azure, AWS, and localhost. And maybe inside AWS, it's going to be relevant for production staging. So we have one way to pass information. So that's why this part is important to make sure that it works. I would love you guys. I'm going to give you, what, 4 minutes, and let's see if it's good enough. If it's too much or too little, let me know. It's okay. Thank you.
Could you tell me how do you get the linting? I mean, the coloring of the .w file, the main .w file, because I get only great text. And
Okay.
it's not...
Okay. This is super important. This is, you have VS Code?
Yes.
So I'm pasting our VS Code application. You just install it, and you get much more than just coloring. You get autocomplete. You can actually run. You see this small icon. You can actually run the Wing console from within over here. This small icon here. From within, I can just click this and see the actual Wing console here if I want. So again, I've pasted the URL for the VS Code extension, and let me close this. This is just going to be great.
Okay, thank you. I found it in extensions tab.
Great.
Oh,
oh, nice. So you went to the extensions tab. Oh, nice. Over here and looked for Wing. Yeah, that's another way to do it. Awesome. Great. So I'm going back to where we are. We're basically right now, we're sending data to my Vite app using public env. This is the public env, which allows me to basically create a key value pair or JSON or a map of strings to value. that allows me to access this information from within my application. Again, without caring whether this is simulator or AWS. This is one of the things I've been doing. I mean, it's one of the things you have to solve every time. Is this an environment variable? How am I doing those things? This is the part of the things that the, not us, but the author of the Vite library took care of. Now, the next phase for us is we're going to add a counter. Why do we need a counter? Now we have a counter, but the counter is not shared. As you can see, if I refresh it, it goes back to 0. So the counter is just an integer inside the JavaScript inside my browser runtime. And we want to add a counter that actually will be reflecting as the actual value that this is showing. And we also need to provide a REST API interface in order to add this counter. So what we're going to do, we're going to bring cloud, and we're going to instantiate a cloud API. As you can see, this thing here. Let's do this. Now, as you notice, I have calls.true because I have a different domain for my frontend and my backend. I need to allow cross, I don't know, cross something origin. I don't know what's the actual acronym for. And I want to
course origin resource sharing.
Thanks, man. Great. Cross-origin resource sharing. Makes sense. Makes sense. And now I want to provide my front end the API URL. So I'm creating an API gateway. API gateway is basically kind of an infrastructure that is provided by all cloud providers. And there's actually kind of also kind of vendors that are providing it. And I want to make sure that the Vite application knows how to go and call REST, post, get APIs on top of it. Now, the other stuff that I need to do, I want to create a counter. So I'm creating a counter. A counter is not, until now we saw a function, a bucket, but now we're seeing a counter. Counter is different because counter is just an abstraction. I don't know what's the actual implementation of a counter. In my localhost, a counter is just an int. In AWS, we are using DynamoDB, which is a it's a serverless database, and we're using it as a counter. So we're basically provisioning a DynamoDB. I mean, the Terraform will create a DynamoDB, which has a field that is an integer that allows me to basically a distributed counter. Okay, and I'm going back here. Now I'm gonna access this thing. So let's access this thing. I'm gonna do API.get, and the get's gonna get a counter, and I'm gonna have an in-flight function. This is something we saw before, and I'm just gonna return the counter.pick. Picking on the counter is actually seeing the value without modifying it. So, and this is a string, and the status should be 200. This will allow me to basically fetch the counter, and we're going to see this in a second. The other part of it, I want to increment the counter, and for this, I'm going to use a post command. Let me get this a little bit smaller, get this out of the way. Sorry, get this out of the way. And the post command will actually increment the counter, which the API of incrementing counter gives me the previous value before the increment. And then I'm going to do old value plus 1. So these are the two functions. Let me save my code for a second. When I save my code, I can actually see that I have the API gateway here with a counter, as you can see. And the API gateway, I can actually go and get the counter value. See, it's 0. I can also go over here and get the counter value. This is actually, this is actually kind of it's actually running Express on my localhost. So the way we are implementing the API gateway in AWS, the equivalent to an API gateway in AWS, locally is Express. We could have done this with any kind of software, web service software. The other part of this counter, I can actually look at the counter. The counter is 0. If I increment the counter here, I can actually increment this, and I go over here. Now I get a 6. If I go over here, back to the Cloud API, and get the counter, now it's getting 6, as you can see here. Hoping you can see it. Let's get this a little bit bigger. Now, I can actually go to the post command, which should actually increment the counter, should be a 7. As you can see, if I go over here, now it's already an 11. What happened here? Oh, I clicked I clicked about this a bunch of stuff. So let me not click a lot. Now it's 12, as you can see. And I can just go back to the counter and I can see the value. So now I have an API gateway with 2 endpoints, a post and a get on a counter, just 2 verbs on the same resource. And it goes and fetch the value of a counter, and I can see this actual thing. And if I'm going to compile this to AWS, I'm not going to see a counter. AWS doesn't provide you a counter resource, but it provides you DynamoDB that we can implement the counter API with DynamoDB. It can also be a Redis. It can be basically any database. DynamoDB is just very cheap if you're not using it because it's serverless and it scales to 0. So at this point, we have the counter here, and we also have the API URL as an environment variable, and we can play with this. So I'm going to give you 5 minutes to play with this. Thank you very much. And I'm going to try to do this for 5 minutes right now. So the next part is we have an API gateway, we have a counter as our backend, and we have a counter that is represented in our frontend. Let's connect both of them. And it's going to be, this is not kind of, I'm not a front-end developer, so I'm just going to go through the phases, and then I'm gonna just copy paste the entire code. So the first thing we need to do is we need to obtain the API URL. We already send this. This is basically kind of taking the API URL. In order to actually kind of use the React hook mechanism, we will have to import not just use state from our app.ts file, but also the use effect. And then the code inside function app, we will basically, as you can see, we will need to change the counter. I've returned a string, so I'm gonna use an A, and then I'm gonna have an increment counter function that just fetches with the post command, fetches the counter with the API URL, and then it sets the counter with the response. Setting the counter is basically part of the React hook system. And then the get counter will do the same, but not call the post function. It's actually going to go the get function just to get it. And we're going to use the use effect method to start this process of fetching the information. And then we have this on click here, as you can see on the, right now it does set count +1. We don't want to do this. We want it to set count we want this to call the increment count function. So that's what we're going to do. I'm just scrolling down because I've prepared an easy function that allows me to copy paste the entire thing. And I'm just going to save this. So as you can see, the same code that we talked about, the API URL, the use effect. And I'm just going to save this. And this is already interesting because the counter here, as you can see, I can increment the counter like this. And if I refresh this, the counter is 17, right? So I've saved this, automatically everything reloaded. I can go to my API. I can post a counter. I'm going to 1, 2, 3, 4. And now when I'm going to hit a refresh, it's automatically incremented. I can also click over here. Maybe I should add some logs. Let's add a log here on the post. This is annoying. Log about incrementing a counter. I'm gonna save this here. We close this. I'm gonna save this here. Now it opened this. And now if you look at this, there's no logs here. And I'm gonna increment the counter 1, 2, 3. And I'm seeing 3 times increment in a counter. Right? And the counter is 24. So I actually have, and if I open 2 pages, 1 and 2, starting to look kind of our end result. But as you can see, it doesn't affect the other page. So if we go back in time, people at my age, this makes sense. This is how the internet used to be. I mean, it started with just static pages, and then there was Ajax. So you actually had to call someone in order to get notification. The worst thing you could do, you can just poll, right? So if I'm going to hit a refresh here, it's going to be 28. And I'm going to click a lot of times here. And now if I'm going to click this, it's going to go into 34. But this one doesn't know it's 34. So we can play this game forever. But we want this to be synchronized. So this is where we are. Just copy paste this the code into the app.js and play around with your application, connect it. It should be kind of straightforward. I'm going to give you 3 minutes for this, if that makes sense. I'm going to close this. So I'm going back here. We're at the phase of edit to call your backend. And basically what we need to do is copy paste this code if everything is understandable. I'm giving you 3 minutes. Thank you. That's going to be our next step, creating WebSockets. We're doing great progress. It's not going to take a long time to have this entire magic happen. So we know where we are. We have everything works in the simulator. We know we have a counter that is connected to an actual counter in the backend. They're synchronized only when you refresh them, right? They're not synchronized otherwise. And we want to basically have a technology that's called WebSocket that basically opens a live connection between the backend and the frontend, and the backend can notify the frontend or the client that there is an event. You can use this in many scenarios. I'm going to use the really simple part. I'm just going to create a broadcasting system that's going to let the client know, refresh, just kind of get the new data. So I'm not going to use this. You can actually pass information on top of this. I'm not going to use this. I'm going to use the old code to actually get the information. And to do this, I'm going to introduce something new with Wing that you haven't seen before. And I'm going to create a class in Wing. So in other languages, class is just code, right? In Wing or in Winglang, class is actually is code and infrastructure together. So all the stuff that we've done here, actually a cloud counter is a class. A cloud API is a class. We're actually calling new. And this means that I can basically package not just logic, but we can also represent this logic in the simulator, in AWS, in Helm charts, on Kubernetes. I can decide how to do this. And so I'm going to go to main.w, and I'm gonna create this in a different file. So I'm going to create. First of all, I want to install the WebSocket. So let's do this. Let's do npm install. You can do this right now, so it won't take time. Npm install save winglib WebSockets, and we can actually take a look at winglib WebSockets documentation, and let's go to the GitHub for winglib and look for WebSockets. And you can see how this is used. This is true for the Vite also. So I can just create a new WebSocket, and then I can connect stuff. I can disconnect, and I can send messages to it. We're going to see this in a second. So I'm installing this. And the other part is I want to create the actual broadcaster class. I want to create a new broadcaster class. I want to put this in a different file. And the broadcaster class has two public API. One of them is a WebSocket URL, because I will have to send this WebSocket URL into clients, right? This is part of the broadcast API, is give me a WebSocket URL. The other part is on the backend, give me an option to broadcast to all the people that are all the clients. So this is what I'm going to do. So let's do this. Let's start with bring, and I'm going to take this from a file. I'm going to do broadcaster.w, and I'm going to do sb. And now it complains because there is no file. I'm just going to create the file, and I'm going to do a bring cloud and bring WebSockets. And I'm going to create a public class called broadcaster. And this exactly looks pretty similar to any kind of object-oriented programming, TypeScript specifically. I'm going to have a member, a public member that is called WSURL from type str, string. And then let's call the new function. The new function is my constructor. And let's create a WebSocket member. So I need to create this member here. Now I have a WebSocket member, and I'm creating it. And I need a database. So when you think about WebSocket, when my broadcaster needs two stuff. He needs the mechanism for WebSocketing, and he needs another base where I can store all my ideas that were connected. This is the two stuff that I need to do. So the database, I can use Redis, MongoDB, SQL. Just for simplicity, I'm going to use buckets because it's going to be very nice to see how it works. So I have a DB, and let's create this database, just another bucket. And let's make sure that, as you can see, it complains that the WS URL is not initialized. So let's use the WB URL, and now we have this initialized. And when someone from a client is connected to my WebSocket, let's put this ID as a file name in the database. When someone disconnects, let's delete this ID as a file name from the database. And the last thing I want to do, I want to implement the broadcast function. And the broadcast function returns a message, accept a message. Oh, I have a typo here. This, no one noticed? Oh my God. I have a message here. So we'll fix this. And what I'm going to do, I'm going to go over my database. I'm going to list all the files. I'm going to get the file name. And I'm going to send message to each one of the files and the message that's going to receive. So it's a very, very simple class. There's nothing to it. Just when someone connects, save the ID. When someone disconnect, delete the ID. When someone asks for a broadcast from the backend, just go over all the IDs and send the message. Very, very simple. And when I save this, nothing happens on the right side. I'm going to save this file. Nothing happens on the right side. It's because that I just created something, but I haven't used it. So the next step for me is to actually use it. So I'm going to go over here, and I'm going to do let broadcaster equal new b dot broadcaster. Now I save it. I should be seeing if I have npm running. So let me run this the simulator. It wasn't running. Now that I have this, I should be seeing broadcaster. This is another typo. I should be seeing, sorry. Now I have a broadcaster. As you can see, a class, and it has a bucket, and it has a WebSocket implementation. The bucket is empty, right? And let's go back to here. I've created the broadcaster. Now I need to pass the WS URL into the broadcaster. So you can see, I'm going back to here. The client needs to know what is the WS URL. So we have the WS, the WebSocket URL is the broadcast WS URL. And the last thing I need to do is I want to broadcast when I increment. So this is the increment. So let me broadcast refresh. So making sure you're following me. I've took one file, I created the broadcaster client. I've instantiated broadcaster client. It has a database and a WebSocket. And I passed information of this to the client. And then I broadcast this upon refresh. Right? I mean, I basically used the broadcast API in order to send events to all the functions. This actually doesn't work, doesn't do anything because no one is connecting to the broadcast. I need to take, there's no clients that are connecting. If I look at this, if I go over here on the bucket, there's no files. Even if I open another and another, there's no file here, right? There's no IDs are added in the bucket. So you wanna go to the next stage. This is I want to go to the next stage. I'm going to do this, and then I'm going to let you move forward. I want to go to the next stage where I connect the React application. Let's do this. So what I'm doing right now, I'm going to the React application. You know what? Let me pause for a second. I'm going to take 5 more minutes out of our time. You can just go over here and just copy paste stuff. I'm going to give you 3 minutes to make this happen before we move forward. I think it's going to be much better. So go all the way until we're going to listen to WS message and trigger data refresh on the client. So let's take 3 minutes to just copy paste code and run it. Also doing the npm install to see that we're getting here, and we're at the end of this. We're just going to see this working in a couple of minutes. You want to copy this code into the broadcaster W. That's one thing. And you want to basically copy this code and just run over your entire application, your main.w, and it should be working and you should be seeing this structure here. Cloud API that is connected to the broadcaster, a cloud counter, and a Vite application. While I'm waiting, I'm going to install React use WebSockets on the front end. So I'm feeding to the front end, and I'm doing npm install React use WebSockets. This is basically a helper function to connect to WebSockets. Righty then. So what we're going to do right now is we have a backend with Socket.io that runs locally. The same stuff's going to run. We're going to see a little bit how it's going to run on the backend side. Now we want to use this WS URL here. The first thing we need to do is import WebSocket from React. We need to actually, we've installed the React use WebSocket. We can see this in the package JSON here, in this package JSON. So we have use WebSocket here. And we're going over here. And we need to do two things. We need to import the WebSocket. And we want to connect the WebSocket to the WS URL. There's a lot of configuration in what to do with reconnect. I haven't, this is not production grade software. The only production grade software is on the backend side. And the use WebSockets, we give it the WS URL. And then when there is an odd message, get the count. So when there's any message, I didn't even kind of check what message it is, go and get the count, which is what we do before the get count is actually calling fetch on the counter. So, and again, for convenience, we have, I've placed the entire code here. This is the 2 lines that needs to be added. So I'm copy pasting this over here. I'm saving this. And let me just see that I have the terminal running. Okay, I have the terminal running. Let me open it. Now I have one, let's see if it's actually working. Let's get this a little bit bigger. One indication that it's working is the cloud bucket. Now I have a file here. It's going to be an empty file. We're just using the ID here. If I'm going to take this tab and duplicate this, I should be seeing 2 files here, because now I have 2 clients that are connected. If I close this and refresh this, the code that should be running is the broadcaster. Oh, the broadcaster on this connect that actually delete the file. So if I'm going to go over here, the file is deleted. And so this is one indication this is working. So let's take this thing, 1, 2, 3, 4. Let's put this here. Now I'm going to click here. Are you ready? I haven't clicked. Clicking. And it didn't work. Why didn't it work? Okay, why didn't it work? Of course I have a bug. My God. Let's see what my bug is. This is annoying. Let me try to fix this for a second. Give me just 1 second to close this. There's something annoying about my setup. I'm going to just reload my window. Okay, need to do this again. Okay. I just want to make sure that I don't have any leftovers because it should have been working.
Yeah, I think it's just that you need to run again.
Okay, I'm going to run it again. Okay. Let's see. Okay, first of what? Damn, everything works so well till now. Why didn't it work? We got the AWS. Let's see that we have this thing working.
It works for me if you want me to.
It works for you?
Yeah, I just followed and copy pasted.
Okay, so something doesn't work for me. I don't know what. You want to share your screen, Roy?
Of course.
Okay, show us. Oh,
probably.
man.
It's amazing. It's amazing. And I can even start another one. Let's take it into the wild. Ah, man.
Nice, man. Thank you
so
for
beautiful. So useful. So useful.
Yep. I mean, we used to have counters just in once. We have to refresh. Now we can actually have multiple counters and multiple page tabs, and it works like a charm. Awesome, thank you. Thanks. I'm glad it worked for you. I will figure out why it didn't work for me. Okay, I'm going to share my screen and just wrap it up. Let me do this for a second. I just want to wrap it up. The last phase here, just making sure you're seeing my screen, Uri? Yeah, okay. The last phase here is basically to deploy to AWS. I'm not going to do this because this actually takes time. This takes like 10 minutes just to see the Terraform apply. I can start doing this with doing kind of wing, compile, TF, AWS, although I need to make sure why it didn't work for me. So it doesn't make a lot of sense. I can do this. It will actually create, it will actually package the Vite using Vite to be served in production and create a Terraform file. But the actual result of this is that we're going to have a CDN using CloudFront that's going to be serving static files and HTML from an S3 buckets. We're going to have the API gateway v1, which is a version of API gateway for Amazon with 2 Lambda functions that actually do read and write on DynamoDB. This is the counter part, the REST API. And the last thing, we're going to have a WebSocket, I mean, an API gateway v2, which actually support WebSocket. They have differences, so we're using both of them. And that uses S3 as a connection store for it. So it stores and gets ID. We're not going to see 4 or 5 resources. We're going to see a lot of resources because every one of those needs permissions to actually get access to another one. There's stuff that are connecting the two. There's another resource between the SDN and S3 that actually connects the two. There's a resource between the REST API and the Lambda function that connects the two. There's a lot of stuff going around here. I think that my main.ts file has went through 900 files, 900 lines, so the Terraform file, and we have 1, 2, 3, 4 Lambda functions, but you can just go through this process and just have Terraform and AWS CLI installed, compile this, run Terraform, apply. It takes some time, but once you're done with this, you can go and basically you can go to the what we saw before, the URL that we have in the beginning, and basically have your here it is, have your application served from CDN, and that's the story. My dream is, or our dream is, write software locally, like we like writing software. Use npm install to bring stuff, and just compile it and run on the cloud. That's what we're here to do. And just join our Slack on winglang.io. I'm going to post this here. And join our community. And let's hope we can work together. This is all open source in order to make this dream come true. Thank you, both of you, Uri and Peter, for this session. And thanks for all the viewer.